shaping and stabilizing the river. The notion from the outset, the competition winning scheme, was that you have this natural meandering river that was straightened many years ago, and then a 90-degree turn was put into it instead of running out through the marshlands and then out into the inner harbor. That's not the direction the river wants to flow. So the first notion was to redirect the river. It wants to take the path of least resistance and make its way out to the inner harbor. That then shapes or informs what the new structure of the urban environment would be. And we needed to provide flood protection, floodplain, ability for the river to overtop its banks, but maintain the urban fabric that's constructed around it. So that in turn created open space, or the parks. And then thinking about how to look at the flood conveyance that we need as a three-tiered system, where we have this primary naturalized channel. We use the existing channel, the Keating channel, the urban edges, the dock walls, as a secondary form of relief. And then in the event of that higher capacity flood, we have the regulatory flood making its way out over top of the spillway into the ship channel. So we've got that as a design criteria item, how we address that regulatory flood event. But there's also a lot of other considerations that have gone into the current design that we're looking at. One would be how to consider the hydraulics and the hydrology of being an estuary condition. So we're on the lake, so we have lake levels that are rising and falling. Also, how we incorporate the desire that there's some recreational use or park programming that's incorporated into here. And then a lot of the performance criteria goes back to that environmental assessment report. So thinking about the conveyance and the capacity that we need of the river system, the habitat that we're looking to provide with this project, and different ways of how to approach it moving forward. Talking more about the engineering and resilience of this system, the two graphics, the two diagrams on the left, just to orient you, the harbor is over here on the left. This is the existing Keating Channel, and the Don River is coming down from the north, and we have two plans sitting on top of each other. This would be a 100-year event showing in color here, the yellow are areas of more intensity of flow, so shear stresses, the actual forces that are looking to rip apart and move the river as it naturally would. The bottom one is the shear stress in a regulatory event, so the regional event. And you can see that in a 100-year event, there's some bright yellows, maybe a touch of orange, but when we get to that regional event, that regulatory event, you get these colors that are red. They're really high shear stress issues. The approach from a design standpoint is that there are many different ways that we're stabilizing the river system. We are looking to maintain the floodplain up to or in excess of the 100-year event, that this channel will not meander, it will not move beyond that 100-year event. When that shear stress event happens, that of the regional, that's when we're looking for that secondary layer of engineering that sits below the park surfaces, so below the landscape, the plantings, and some of the other techniques such as anchored wood here on the right and stone armor on the left. And that's what keeps the material, the contaminated material that's been capped, in place, so it's immobile. So there's a secondary level of protection underneath that surface treatment. So how do we go about the surface treatment? Looking at the stabilization strategies, we have moments such as the purple color here, which would be that anchored, that armored stone. So very common material that you see at many areas along the waterfront right now that faces the Lake Ontario. In areas that we have orange, orange is where we're thinking about actually using solutions, this lighter yellow orange, where we're actually using vegetation that has bioengineering type of approach, where we're using fabrics that decompose with time after the roots anchor down that planting soils. That's what stabilizes the stream bank edges. And then other areas, such as that previous image, where we are using wood, creating anchored, where it's actually anchored down into the ground plane. We're using crib walls and different techniques to interlock that material. And that's what stabilizes some of the more erosive areas of the channel meander. So this video actually will go through the base flow condition, where the water level is. You can see the edge of the floodplain, And then as that regulatory event comes, you can see where the rest of the channel, the bottom of the floodplain, is able to accept that regulatory flood event. So there's a very dynamic relationship between the edges of the park starting to register what type of storm events are coming down through the river valley system. And what's important to understand is that from a park design standpoint, we're looking at what happens above that high water line that you just saw. That's top of bank. That's how we describe it on the project. The activities, the programming that happens below top of bank are planned to be able to address or absorb this type of storm event. So we're not putting, for example, playgrounds below top of bank. We're not putting some of the more typical park recreational features that can't just absorb these changes to the river system below top of bank. We'll have nature trails. We'll have other types of activities that get you down below, but not some of that other programs that need to be in a more stable environment.